All right, in this very common exam problem, we want to calculate the difference between the change in molar enthalpy and the change in molar internal energy for this combustion reaction right here at 298 Kelvin. And we're going to do that by starting off with the definition of enthalpy, H, which is defined as the internal energy plus the pressure times the volume. So this is straight up enthalpy, but to get the change, we just take the change of each of these terms right here. And now the change in pressure times the volume is going to change mostly due to the change in volume of the gas. The liquids will change, but it's really the gas that we care about. So because that's going to create the greatest change in the volume, not so much the liquids. So we're going to use the perfect gas law, PV equals nRT, and substitute that in for PV right here. And at this point, we can just transpose the change in molar internal energy over and see this difference. This is what we're solving for here, equals the change in the moles R times temperature. Now, temperature is constant, so the difference in the moles is going to be difference in the moles of the gas, because that's what's going to change the volume appreciably. So if we plug in our numbers, and based on the balanced equation, we have 7 moles of gas produced for every 9 moles of gas that react. And when this occurs, we react 1 mole of C7H8. So that'll give us a molar quantity because these quantities are per mole. And in this balanced equation, we have a 1 right here, a 1 mole. So 7 minus 9. And it's at a constant temperature. Now this reaction will produce energy as heat, and it might heat up. But imagine the reactants are at 298 Kelvin. It reacts, and then we allow it to cool back down to 298 Kelvin so that overall the temperature is constant. Cool beans. So we just plug that in, and the difference is negative 4,960 joules per mole, which is the same as negative 4.960 kilojoules per mole. It's negative because the volume goes down because we are kind of reducing the number of moles of gas. Okay, y'all, hope you enjoyed it. I got tons and tons of other exam problems on thermo, many other videos on concepts and things like that, and other aspects of chemistry, math, and physics. So good luck on your midterms. Good luck on your final exams. I know thermo is not the easiest course, but the more of these problems you do, the better you'll get. All right, see you in the next video. Cheers.